Okay, so today we're going over special right triangles. So the objective is students to learn the properties of the two special right triangles. So we're going to start off with the first one. It's called the 30, 60, 90 right triangle. And these are the properties of this triangle. So we're going to start off with the 30-degree. So the side across from the 30-degree, we're going to call that x. So that value is x. Okay. Now the hypotenuse, we're going to say that's 2x. And then the adjacent side, that's x times the square root of 3. Okay, so that's how we set it up here. Okay, next triangle, so 45, 45, 90, right triangle. In this one, these two sides are the same. So we're going to call both of them x. And then the hypotenuse is just x times the square root of 2. Okay, so example 3, we're going to solve for these missing sides. Okay, so in the first triangle over here, so we know these two are the same. So if this is 2, that means this is also 2, which means the hypotenuse is 2 square root of 2. Okay, and let me go to the other one. Still 45, 45, 90 triangle. So we know these two are the same. So what we know here is that this side here is x square root of 2. And these two here are x and x. Okay, so what we know here is that our x is 5. So that means that this side here is 5. And this side here is also 5. Okay, so that's the pattern of a 45, 45, 90. The two legs here are congruent, the same size, same value. And the hypotenuse is the set value, the leg, times square root of 2. Okay, example 4, we're going to solve for these missing sides. So here we have a 30, 60, 90 triangle. So again, here if we start off with the 30, we know this side here is x, which means the hypotenuse is 2x, or 2 times 10, which means this is 2 times 5 is 10. So that's 10, 5, and that means this side over here is x square root of 3, and we know x is 5, so it's going to be 5 square root of 3. Okay, so the next one over here, we know we have the 30 right here. So across from the 30, this is x. This side over here is 2x, and this is x square root of 3. Okay, so here, so that's 2x. 2 times 2 gives us 4, so that means that this side here is 2, which means this side over here is 2 times the square root of 3. Okay, so here, complementary angles is just two angles whose sum is 70. So for example, we could have here like 70 and 20, because 70 plus 20 equals 90. Another two I could think of is like, let's say 14 and 76. Because again, we have here 14 plus 76 equals 90. Just like that. So next example, find the complementary angle. So here we say the complement of 40 is 50 degrees because again, 40 plus 50 equals 90. And the next one, the complement of 73 degrees is 17 degrees. Okay, 17 degrees. And here because we say 73 plus 17 equals 90 degrees. Over here, the complement of 10 degrees is 80 degrees. And because we say 10 plus 80 equals 90 degrees. And the last one, 34. So the complement of 34 degrees is 56 degrees. And the reason for that is because again, 34 plus 56 equals 90 degrees. And then last example, here we say sine of an angle is equal to cosine of its complement. So here's 70, and over here we put 20 degrees. Because again, 70 plus 20 is equal to 90. Okay, the next one. 14, and here we put 76. So sine of 14 is equal to cosine of 76. And that's because we say 76 plus 14 equals 90 degrees. And same thing with 43, cosine of 43. So we say 43 is 47. So here, because 43 plus 47 equals 90. And over here, cosine of 40 is equal to sine of 50 degrees. Because again, 40 plus 50 equals 90. And another thing I'm going to do here is find the values of those trig functions there. Okay, so sine of 70, this gives me 0.93. Same thing with cosine of 20. This is 0.93. Next one, sine of 14 is 0.24. Same thing, cosine of 76, 0.24. Okay, next one, we start with cosine of 43. That gives us 0.73. Same thing, sine of 47 is 0.73. And last one, here we say cosine of 40. That gives us 0.76. And same thing, sine of 50 is 0.76. So we're done with today's notes.